Perplexity is one of the metrics used to evaluate performance of a Gen AI model. It is often used to evaluate and tune models during the training process. In this video, we are going to uncover what is perplexity and the mathematical intuition behind it. So let's dive in. So what is perplexity? Basically, in simple words, it is just a matrix which tells how good is your Gen AI model. It measures how confused the model is when making the predictions. In a more subtle way, a good language model should assign high probabilities to the correct word, and to the bad words, it should assign, or non correct words, it should assign very low probabilities. This will become very clear through this example. Now, suppose I have a Gen AI model here. Let's me call it Gen AI model, GI. And I have a word here, the cat sat on. After this, these are the three words through which I can choose which word fit in here best. And this model will decide what would be the next word after cat sat on the, it should be mat, dog, or table. The probability distribution for this is, for mat I have 0.5, for dog I have 0.2, for table I have 0.1. So the correct word here is mat, and for the correct word is has assigned high probability. This is what perplexity tells you. So, and here if the model assigns a higher probability to the correct word, which is met here, it has low perplexity score, which is good. And if the model is uncertain and assigns low probability to the correct word, the perplexity score increases, which is bad. For example, here it says instead of probability 0.5, it says 0.1. And instead of table, let's suppose here I have one more word, which is train or cup, and it says probability of cup being there is 0.5. So if it assigns a wrong word more probability, that means perplexity is increases, and more perplexity, that means it's not good. Now let's try to explore perplexity from mathematical angle, the mathematical intuition behind the perplexity. By definition, perplexity is based on entropy, which measures the uncertainty of a probability distribution. The mathematical formula for perplexity is PPL equal to 2 to the power h of p. Here, h of p is cross entropy of the probability distribution. And the actual formula of h of p is 1 by n, which is this, and the sum of all the log from wi to w1 is to I minus 1 from 1 to n. Here, n is the total number of words in the dataset, this n. So, n is total words, and this probability wi of 1 is to wi minus 1, it is the probability assigned by the model to the word I given the previous word. So actually in LLM model, what happens if I have a word here, I own a. So if I want to fill anything here, what word will be here will be based on the tokens which has appeared earlier. So if the right word for here would be I own a bike, but a wrong word for here would be I own a mountain. Of course you can own a mountain, but just to make things really simple, let's suppose we cannot own a mountain here. So in a language model, entropy represents the average amount of information, which is bits, needed to predict the next word. In a larger sense, entropy means the uncertainty. And if you have read thermodynamics, in there entropy generally means the randomness in nature. So if entropy is low in the context of our LLM and Gen AI, suppose I am telling entropy as E. So if the entropy is low, this means the model is confident. I am representing model with M. So if the entropy is low, that means model is good and it is more confident. Perfect. But on the other side, if the entropy is more, that means randomness has increases. So if there is randomness in the model, sorry, if there is randomness increased, that means the model is not really doing any good to us. So there is an indirect relation between entropy and the model in performance. Now let's try to decipher this formula in more detail. Perplexity is an exponential function of entropy because it represents the effective number of choices the model considers. This is a key to understanding why perplexity is equal to 2 to the power h of p, where h of p is the measure of entropy. Suppose we have this model where entropy is equal to, suppose, 1. Let me write it here. So suppose we have this 1 here, and again we have 2 here, and again we have 3 here. So what happens if the entropy is equal to 1? So it becomes 2 to the power 1. So it means it is uncertain as fair coin flips. So we have two choices here, and the moment we have entropy is equal to 2, so it would become 2 to the power 2, which is equal to 4. So the model can choose from 4 words, which is the best word. Ideally, it basically means it is uncertain as choosing between 4 words. Similarly, if entropy is equal to 3, here it becomes 2 to the power 3, which eventually becomes 2 cross 2 cross 2, which is equal to 8. It means it is as uncertain as choosing between 8 words. Very simple to understand. So this mathematical formula clearly gives us the moment this entropy increases, this perplexity score also increases. That's why whenever we increase the randomness, the perplexity increases, and more perplexity means the model is bad. So this model, sorry, this formula PPL equal to 2 to the power h of p helps us translate the bits of uncertainty or entropy into number of choices as we see here. Now let's try to decipher the perplexity score and what it means in a better way. Let's try to understand it through an example. Suppose I have the probability distribution here. So probability distribution for word 1 is 0.4, and for W2 given word 1 is 0.3. Similarly, we have 0.1, 0.1. So, and if at all I have to calculate the perplexity score, we know the formula 2 to the power h of p, where h of p is the randomness. So PPL is equal to e to the power. When we take log on both sides, this is the actual formula. So e to the power and 1 by 4, and we take the log of all the probabilities distribution here. So this becomes 4.52. Very easy mathematical calculation. It's super easy to navigate from here to here. So what is this 4.52 here? So this 4.52 means the model has perplexity score of 4.52, meaning it is 4.52 times. It's very important. It is 4.52 times uncertain about the next word. That's why we say the less the perplexity score, better the model. So the less uncertainty in the model, the better the behavior of model. Now to interpret the perplexity score, whenever we are trying to interpret the perplexity score, in an ideal case, a good model or good Gen AI model perplexity score range is between 10 to 100. Anything beyond 100 is not considered a any good here. So if at all you see the table here, so for GPT-4 it is less than 10, and for GPT-2 it is between 20 to 50. So whenever we are trying to create a new Gen AI model or new text based Gen AI model or LLM models, we try to compare the perplexity of scores of different model, and in an ideal way, an ideal Gen AI LLM model will have very less, or I would say like in GPT-4 it has really less perplexity score. That means this is the best model which we have got till now. That's super easy to understand. This brings us to most important question. How do we use perplexity score when we are doing regular Python programming? So we have evaluate library from Hugging Face itself. So in Hugging Face we have this library called evaluate. You just need to import that library, and from there you can load the perplexity score. And this is how you do the perplexity measurement. So inside perplexity.compute, you call what is the model you are trying to compute, and the predictions. So the predictions needs to be supplied in the form of array. So inside array you can supply the predictions, and here you will be getting the perplexity score inside the results. And for this sort of, suppose this is the text here, for this test this is the perplexity score I'm getting 32.45. Not that bad, isn't it? So this is a quick summary of how easily you can use the evaluate library from Hugging Face. to call the perplexity. It's super easy. The key factor here is to understand what goes inside the perplexity rather than just calling the function. Now, just to summarize, what are all the things we looked at? We looked at what perplexity is, what is the mathematical intuition behind it, and how do we use perplexity, and how randomness in a perplexity or in a Gen AI model destroys the whole model functionality. Now, what perplexity tells us? It tells how well a language model predicts the text. It helps compare different models. So, if you have created two, three models and you want to know which is the best model, this would be one of the metrics to be considered. Also, lower value means better prediction. This is very important here. Lower perplexity means the model is better. But what the perplexity doesn't tells you, that is also very important. Now, if the model generates meaningful or coherent sentences, there is no way perplexity can tell you. And if the model is diverse in the response, that is also not possible through the perplexity score. Also, you cannot tell if the model is biased or hallucinating. So, if there is any case of biased or hallucination, this is very important, because ML models usually hallucinate these days very easily. I don't know. I think it's the type of data to which they are trained on. It's pretty normal these days. So if the model is hallucinating or not, or if it is biased or not, there is no way through the perplexity score you can tell. There are different metrics to it. Like we can use BLEU or we can use Rogue. So this is a quick summary what we looked at in this video. I hope you have learned something on what is perplexity, how do we use perplexity. It's a tongue twister, believe me. Hope to see you in next video. See you.